Okay, quick lesson on probability for today. So, we are going to be doing the simple probability today. So this should be a pretty easy one. We'll talk about just the basics. So here we go. An event is where, for instance, let's say you flip a coin. All right, this thing happened, and we can, if we flip a coin, get two different things that can be the outcomes of that. You could either get heads or tails. And if you make a list of them like that, heads and tails, you're making a sample space. The outcome is that it comes out either heads or tails. The sample space is a list of all the possible outcomes. Okay? And the probability is what you want to happen, how many things could make you win, over how many things are possible. So I often, if I'm going to sum it up in 2 words, it's what you want over what's possible. It's the outcomes that you want over the outcomes that are possible. And your answers are always between 0 and 1. So again, if we're flipping that coin, what we want is heads, let's say. Then you have one thing that you want to happen out of how many things could happen? 2. So 1 out of 2 is 0.5. This is a good answer. This is a good answer. Usually the books like to use just decimals. We're actually okay with fractions or decimals on today's little assignment. Okay, theoretical probability. You can say that on a coin, you should have a 1 in 2 chance of getting what you want, either heads or tails. The one you want out of the 2 that are possible. On a dice, or a die, if you have only one of them, you have a 1 out of 6, because there's 6 things that can come up on a normal die, and you typically only get one of them where you win. Let's say you only win if you get a 5. And you have one thing that can make you win out of 6 things that are possible, 1 and 6. Decimal for that, about 0.16, or maybe I think it's 0.161, so I think it rounds to 0.16. All right. So what's the probability of rolling a 6-sided die and getting a 4? Well, there's one thing that makes you win out of 6 things, so 1 and 6. An odd number. How many things make you win? There's 3 things that make you win. 1 and 3 and 5 out of 6 things possible. So 3 out of 6 simplifies to 1/2. And a 2 or a 5, try to remember that or means add. So it's 2 out of, sorry, there's two things that can make you win, a 2 or a 5. So 2 things out of 6, which simplifies down to 1 and 3. All right. What if you're doing the spinner game? Probability of landing on green. Well, there's only one green spot out of how many spots are there? 2, 3, 4, 5 spots total, so 1 out of 5. Probability of landing on red? 1 out of 5. Because there's 1 red, 1 out of 5 total. Landing on yellow? There's 1 again, 1 out of 5. Landing not on red. Well, then I could win here, or here, or here, or here. And or means add, so 1, 2, 3, 4. You add them all up, you get 4 out of 5 things that could happen. Not landing on red is a 4 out of 5 chance. If you were to select one shape at random, okay, I pick that one. What was the probability of selecting a circle? Well, there were 3, 4, 5, 6, 7, 8 circles. 8 out of how many things are there? Well, there's 5 this way by 5 that way. Makes a total of 25 things, 8 out of 25. That was your probability of selecting a circle. I picked the heart, but I knew what was coming, so I was cheating. Okay, so how about the greatest probability of getting selected? Well, there's a lot of squares. In fact, if I count them up, there's actually way more squares than anything else. So a square is the shape that had the greatest probability of being selected. It never asked what that probability is. It wouldn't be too hard to do it. 3 plus 1 is 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 25 was your probability of that. All right. This is experimental probability. That's where you actually flip a coin. And would you expect it to come up heads 3 times in a row? No. In class, I actually flipped 4 tails in a row before I finally got a heads. So an experiment comes out with values that aren't what you would theoretically expect. Notice the difference. Experiment is where you actually do it, and theoretically is where you just think, well, it should be every other one is a heads and then a tails and then a heads and then a tails. All right, so experiments are more lumpy and they don't actually like come out perfect like you would expect them to, where you'd expect it to come out exactly half the time. You should get heads. In the real world, the experimental probabilities are often different than the theoretical probability. All right. So, for instance, on this one, my sample space is a list of all the things that could happen, and that's a list right there. Just bring that down here. What's the probability you end up picking a pair of boots? What I want is boots. How many boots were there? There were 2 pairs of boots. So 2 out of how many different things were there? 4 and 6 makes 10, plus 2 is 12. 12 things could happen. 2 out of 12 simplifies to 1 out of 6, which we already said is 0.16. There we go. Example 2. What could you pick? Sample space. Well, I could get 7 different of those, 5 different of those, and 2 different of those. So that makes a total of 14 different things could happen. And you technically have to list all of them. So I'm just going to draw an arrow to those things. What's the probability you get a pair of white socks? Well, what I want over what's possible. What I want, 5 different things would win for me, the white socks. Over what's possible, we'll add them all up. 7 and the 5 and the 2 makes 14. 14 different things could happen. 5 out of 14. What's the probability to grab this or, remember that or means add? That. All right, white socks. Well, there was 5 ones that would make me win there. Or means add. Fun print, 2 pairs of those. So can I just say the answer is 7? No, that's not a probability. 7 out of, well, there's 14 things possible. So 7 out of 14. 7/14, 1/2. Okay, last example, and I feel like you've got the basics, and then we'll talk about more advanced probability tomorrow. Your friend asks you to play a game. You roll a die, and if it lands on 2 or 4, you win. If it lands on an odd number, your friend wins. Well, what's your probability of winning? Well, if you get 2 or 4, that's 2 things out of 6, you win. But your friend gets an odd number. That could be a 1 or a 3 or a 5. You see how they have 3 different ways to win? They have a 3 in 6 chance for your friend. They have a better probability than you. They have a 50% chance. You have a 2 in 6, which is like a 1 in 3, which is like a 33% chance. Your friend is more likely to win. What is the probability that neither of you win any money? Well, try to figure out what would make that happen. A 1? No, this guy would win if you got a 1. A 2, you'd win. A 3, you're back to your friend, would win. A 4, neither one of you win. Interesting. Oh, wait. You've got a 4. My bad. A 5, your friend wins. A 6, the only number that neither one of you wins is a 6. So here's a really easy mistake to make. They say 6 out of 6. But this doesn't make any sense. There's only 1 6. So you should put a 1 there. 1 out of 6. 16% chance that neither of you wins any money. Because there's only one thing. If you roll a 6, then neither one of you wins. Okay. So we're going to go over the rest of this tomorrow, starting with the fundamental accounting principle. And today was a pretty short day. All you had to do was the Schoology quiz, just the first 4 questions, and don't even hit submit. We'll finish the rest of it tomorrow. And that's all I've got for you for today.